Hi guys, I hope you're doing absolutely amazing so far. In this video, we'll talk about the instrument profiler. We'll talk about the actor and non-isolate keyword. So we are going to talk about non-isolate keyword because in the previous video, we have seen actors and we talked about actors in very much detail. And there seems to be a problem with actors. So when we are running 5 concurrent tasks, which is accessing the isolated property of the actor is going to serialize the access to that property. And that basically means the first task is accessing it, modifying it, the first task is running, and during that, all the other 4 tasks are just waiting, right? And here we are not taking the advantage of full potential of the concurrency. And that is something we can do with the help of non-isolate keyword. So in this video, we are aiming for the instrument profiler, the problem of the actor, and how to solve that problem using non-isolate keyword. So we will start off with the macOS application we are creating, which takes a bunch of files and it will compress those files. So we are writing the code for the compression, that is our files will be compressing. So we write that code. And while the files are compressing, we will showcase how much percentage of the file is being compressed so far at this point in time. So we are showing that progress as well. For that, we have to write the UI code. So what we are doing right now is we are going to write both the code for compressing the file and code for UI updates together in one class. And we'll put this one class on the main thread. So what you're trying to do basically is the main thread will do all the work. That is the work to update the UI and the work to compress the file as well. And this results in the main thread being blocked. It will hang our application. Now we will explore this problem and we will understand how to resolve this problem, and that is where we use actors. So let's understand the problem first. So grab our Xcode and let's dive. So here on the screen you can see I have 4 windows. The first is the instrument profiler. Here we have our Xcode. We have the application which the Xcode is running, and we will explore the UI in a second so that we get first familiar with the application, what our macOS application is doing, and then we will explore the concurrency part of it. Yeah. So here we have the bunch of files that we will be giving to our application and it will compress it. So let's close the instrument so that we'll get to understand where to actually can open the instrument. We will close the application as well, and let's take a brief look on. So here we have our content view. We'll start off with that. Let's run this as so. Before we understand the content view, let's see the name of the file. I have named it running all on main, since we are running the compression code and the UI updation code all on the main thread, and it is just a SwiftUI project. And in the content view, now we have the compression state, and it is the class which is where we are doing all the work of compression and updating the UI as well. So when we talk about the UI, we have the select file button and the compress file button. We select the files, give it a bunch of files to compress, and it will showcase the files we have selected. It has not started compressing yet. We will click on compress files and then it will start the work. It will also showcase how much of the file is being compressed in percentage, and after the compression, how much is the file size in KB. So in the content view, we have the vertical stack where we have the list of the files we are displaying with the text, which is the name of the file. Progress view, the text for the percentage of the progress, and the compressed file size, how much after the compression the file size is. This is the list of those files. We have the horizontal stack for our 2 buttons. First is the select file and compress file, which is right here. When we select the files, it will just go to our, which is just right here. It will open the panel, let you select the file, and the compression state dot files will get the URLs of all the files. It's basically just selecting the files. For it to compress, we'll click on the button compress file, which will actually run our function. And let's check out this class now. So this class is utilizing the code for compression. So let's get over with this small piece of code, which is the class compression utils. It has one static method, compress data in files. We're just going to give it the URL of the file and it will just compress it. Now, here we have in the class two functions, the compress file, which is utilizing that compression utils dot compress data in file. And we have the compress all files where we are just iterating first over all the files and creating the task for each of the file. That means we are creating tasks separately for each of the files. Means all the files will start the compression at the same time. There will be threads equals to the number of tasks, and number of tasks are basically equals to the number of files we have, and all the threads will pick it up, start the compression work concurrently. This compress file method is what we have here. It will take the URL, it will in the log, it will update that starting compression, it will do the compression, and once the compression is done, we are not doing anything about it. We'll be logging that finished compression for this file. And that is it. We have the file status for handling some progress related and compression related work. And that is how the code is. We don't have to dive deeper into this code. We are just focusing on the performance of it and understand the instrument profiler. So I will come here and give you a walkthrough on the application as well. So we have selected the file and we will click on compress, and here is where the logs will be appearing, as in when it started the compression and when it finished the compression. So let's run it. And okay, the main thing, we have put all the code on the main actor. This basically is equals to putting the code on the main queue so that the main thread will pick it up and will execute it. And let's make it smaller. Actually, I will pin it to the top right and we'll keep it here. This one is, let's run the compression now. Here we have our X code. I will make it a little bigger so that we can see our compress all file, which is just creating tasks for each file. Now let's start compression. You will notice that it's not showcasing anything related to the UI. So the UI code is not working and our application is, hang. If we come out of the application, you can clearly see our application is hanging, and it is because we are running the compression code and the UI code on the main thread. Only when the compression is done, the thread will be free and then it will update the UI. You can see now after so much of time, it updated the UI. It says the compression is 100%, and after the compression, the first file, the first large file, is now 2499 KB. So if you see the logs, it says starting compression, first file, it finished it, and then it started compression for second large file .mp4, finished compression for second large file, and then for third, for fourth, and for fifth, and then for sixth. You can see it did the compression serially, one by one. Why? Because we were running it all on the main thread. The compression code, compression of 6 files, it was supposed to start concurrently because we have separate tasks for it. But since we had only one thread can only pick all the 6 tasks. And since it's a main thread, it picks all the tasks, it compresses those files, it does all the tasks one by one, but it leaves the updation of the UI for the end. Once all the tasks are done, it updates our UI. Now let's analyze this with the help of instrument profiler now. So I will stop the application I will run the application. We will click on Xcode, go to our Open Developer Tools and Instrument. We'll select the Swift concurrency and I will pin this on the top left. Now, since our application is running right now, we can start recording on Instrument. For that, we just click on this button and you can see it has started capturing a lot of data. Right now, you can see here, it has the name of the application that is running all on main, and we have to select it if it is not already selected, and it will capture all the concurrency related data here for your application. And it is important before you record, your application should be running. Now let's select the files and let's compress. You can see as soon as I click compress, there is a lot of data that the instrument is actually started to capture. And our application, you can see my mouse, it's hanging right now. It is doing the compression of all of the files. All the tasks are running one by one and it is running on a main thread. The main thread is not updating any UI, just doing the task of compression right now. And as soon as the compression is done, it updates the UI right now. You can see it first updated the logs and also almost at the same time it updated the progress as well. Now we have a lot of data already captured by our instrument. We can stop it, and since our application is done with all the things, we have enough data, almost everything that we need. So we will pause the instrument and we have a lot of data to analyze. So as we were expecting that our application will hang, it did hang, and it did compress all the files one by one. And let's explore that with in here. So I will make it bigger. And there is a lot of information here, a lot of windows. We'll go through it one by one. We'll get a tour understanding on what it is this instrument is showing us, and then we'll explore the data regarding our application. So finally, we are on our instrument now. Let's explore this A to Z. Starting with this portion, it's just we have the runs. The first run, this is our first run. If we capture or we run our application again, capture again, we will see that the second run here and nothing else. Let's start exploring this portion. We have to select our application here. So right now I've selected the application which we are running and for which we are gathering a lot of data. We can select from any of the installed application, Acrobat, or whatever application you have on the system. You can track any application, see how the concurrency code is running for that. And running applications also you can select from that. System processes, if there is any concurrency code behind any of these system apps, then you can just, or these processes, you can just explore that. App extension as well, I've selected running all on main, and that's it. Here we have the instrument. This is a lot many other tools that we can utilize in the instrument. We don't need it right now, so let's explore this some other time. After this, we have this target all tracks. So target is basically this bunch of tracks you are seeing here on the timeline. So this is the first track on the timeline. This is the second track on the timeline. So these are a bunch of tracks we have. So we have in the target couple of these. In all tracks, we have all the CPU cores. So if you want all those tracks here pinned, then you can just click on all tracks, and along with the targeted tracks, you can see the CPU 0, 1, 2, 3, so on till 7. So my uh, laptop is actually MacBook M2 Air. It has 8 core, and we can see we have 8 threads here, 0 to 7. And here is our running all on main application. So this is our application. If you click on that, You will see a lot of related data to it, and we'll come to this in a moment. Let's go back and select target right now. Now here we have it's a filter for our tracks. It is something that will the instrument will pick it up. We don't have to select it or configure it. It will, as soon as we pick our application, it will configure itself. And now let's come to our this window, and then we'll come to this window and this window later. So I will close this one. So here we have our graphs, and when we talk about Swift tasks, we have running tasks, alive tasks, and total task graphs here. So since we had the 6 tasks for our 6 files, right? Those are the tasks it is talking about here. So total task is basically the total number of tasks we have at this point in the memory, and alive tasks are the number of tasks at this point or at this point present, and the running tasks are telling us about how many tasks are running simultaneously or at the same time at this point or at this point in time. So when we talk about total task, if you hover here, you can see the black label saying 6, and this is the total number of tasks, right? So we were creating the task. If I for a moment just make it smaller and see our code, this task, we had 1, 2, 3, 4, 5, 6 files, and for every file we are creating one task. So we have total 6 files and 6 tasks. Now let's come back to our instrument. If we hover here, you would see 6 in this black label right near to the mouse. And let's talk about a live task. If you hover here, it will say 6, but these were the tasks which were live, and the running task, you would hover, you would see 1. So at the time, only one task was actually running. If you see, till from the start till the end, only one task was running actually on the application. So total there were 6 tasks. At this point it was 6 tasks, and the first task was running. After it was finished, you can see here it was 5 tasks. Then it was 4 tasks, 3, 2, and left one only in the end. That basically means the running task was 1 when it was running the first task. The total task was alive was 6. Once the first task has finished, we have total 5 tasks remaining, and when the second task was running, it started here and it end here, and after that we have 4 tasks remaining. When the third task was running, it started here and it was running till here, and after that we have only 3 tasks running. So our fourth task is running, and then our fifth, then sixth task is running. But you can see the total number of tasks were 6. The alive is 6 here. Once the main thread is done executing the first task, the remaining were 5 here. And you can see the main thread was executing this one, and then this one, then this one. You can see the main thread was executing the first one till here, then second task, then third task, then fourth task, and then fifth task, and then sixth task. And we saw that our application was hanging the whole time the compression work was going on. And as soon as this all the 6 tasks, the task for compression is finished, our main thread was free, right? It says, so you can see it says severe hang here, which was the hang was till the point here when our task were running. The moment the last task was running and it finished, after that our main thread is free. So the hang was right from the start, from the first file compression till the last file compression, or the first from the first task compression till the last task compression. And that is it. This is Swift task all the tasks that is there in your application will be having here their representation. The graph is basically telling about total number of tasks, how many tasks are alive at this point, and how many tasks are running concurrently at this point. So all the time there was only one task running, and because it was our main thread, the main thread is only the one single thread out of all the cores. There is always one core which is the main core. We call it the main thread. And there is only one main thread in our computer always. So there is only one single thread which takes the task one by one. Although our tasks are ready to picked up in a concurrent manner by the multiple threads, but since we put our code here, let's code our code here, we put it on the main actor. Because of that, only the main thread can pick it up. And when it picks up, the application hangs because the main thread is meant to do only the UI updates and not do any heavy lifting. Now that is all there is about the Swift tasks. We have Swift actors. If there were any actors we are using in our application, then it will showcase the number of actors here. Right now it says 0. We are not using any actors at the moment as well. Time profiler talks about the CPU usage, and it's just a graph about how the CPU usage was throughout the application when it was running. If there were any hangs in your application, it will showcase right over here with the hang title here. You can see our application was hanging right from the start till the end when all the 6 tasks were running. When it did end, the only information we have is the total task, which just talks about the task which were there, total number of tasks in your application. And this hang did finish here. This is our application. When you say running all on main, this is the name of our application. If you click here, you will get hangs. So the hang was right from the starting till the end. CPU usage, app lifecycle. Here, if you click, you will see the process, the data it is showing regarding your application are the hangs and time profile. So hangs is basically this one, and time profile consists of CPU usage and app lifecycle. With the help of command, I click command and you can select both. So it will showcase hangs, and the profiler, which is profile, will showcase CPU usage and app lifecycle. Now, as soon as we click on our application, you can see in this window, we get to see a lot of information, right? So let's go through it. So this is the tab where we will see what kind of details we want to see in the window. So here it has Swift task. So let's explore this one first, and we'll come to the hangs and time profiler. So it says when we have here all of our tasks when it started, the duration for which the task was running, the thread on which it was running, and the Swift task that we have. So we have the first task. You can think of this 0x3. It's the hexadecimal representation of our task. And the this is our first task. If you click, you will see this line will move. If I click on second, it will tell you when it is started. It is just like when you edit the video, and it just tells you on the timeline where you are. So this task started at this point in time, and this is our fourth, fifth, and sixth task. The sixth task started here and it ended here. Now let's talk about the thread it was running on. So you can see the thread has this hexadecimal representation and it ends with 3 3, and all the threads are ending with 3 3. So this is our main thread, and which was running all the tasks one by one. The duration, the first task was running for 5 seconds here, and we can see if we click here, from here till here it was 5 seconds. Total 5 into 6, 30 seconds is the whole time the application was running, compressing our files one by one. Now what we can do here more is you can actually see a bit more detail about each of your tasks all you have to do is right click here and pin the task on the timeline. I will bring it a bit down, and you can see our task, the first task was running right from here till here. Just like this, we can put all of our tasks on the timeline. So let's do it. Click on the application and right click, pin this task. And you can see this is our second task, which was running right after the first task finished. But when the first task was running, this one was just getting created. And let's click back on our application. Let's pin the third. Click on our application, pin the fourth. Click on our application, pin the fifth. Click on our application and pin the sixth. And now we can actually visualize our tasks. So the very first one talks about the first task. So you can think of this hexadecimal number as the name of your task. And the task state is what it tells here. So the running state, and it was running from till this point, from this point to this point. This is our second task. So you can see x3 is our first task, x4, x5, x6, x7, x8. These are our 6 tasks. And you can clearly see that first was running, and only after that the second was running, then third, fourth, fifth, sixth. And it was running on our thread. Let's pin the thread as well. So let's click on our application, which is this. And you can see these were our tasks, and this is the thread it was running. So we can right click and pin thread in timeline. When we click, let's come down, drag it a little up, and here we can see is our thread on which all of our tasks were running. Here we can see we have the option to see what all things you really want to see on this track. So let's click on task state, and I would see these are our tasks and their states. It was running from this to here in the point in time. And that is how easy it is to actually look into your application, how the concurrent code is being executed. Let's see what more we can do. So here we have pinned the task, pinned the thread it was running on. So if you click on the application, you would see a lot more information than clicking on separately on one task. So when you click on one separate task, you will see a narrative. A narrative is just like a story, what happened with the task, when it actually got created, after that it was running, whether it got suspended by the main thread or not, and when it actually finished executing. So it got created, and the creating, it was creating for 4 milliseconds. So it says ran for 5.01 seconds on running all on main. And this is the main thread as it is ending with 33. And it says this is the name of our application. This is the ID, and starting at F3 with priority user initiated. If you want to explore a bit more further from the narrative, what you can do is just right click and open in source viewer. So if there is some problem with the code and you can see it clearly in the narrative, you can just right click, open it in source viewer. It will tell you exactly where in the code the problem is. Right now this is actually a dynamic library. If you right click this, it will show you a problem saying error because it's a dynamic library. We are not allowed to see into that. But it says it was running on the main thread, that is 33. And here we see reference to task was held for an additional 64 microseconds, not millisecond, but microsecond. So this is the narrative about our first task. If you click on the second task, it will say the same because the same thing happened. The creating for 5 seconds, then it ran for 5 seconds, and the creating for 5 seconds is basically the time when the first task was running, right? Since for the first time there was only 4 millisecond creation time, and for 5 seconds it did run, And here also it says 5 seconds. Here you can see creating. So narrative actually gives you about the story about your task, but pretty much a lot more you can see here as well, that it is getting created here, running, and if it was queued also it will appear here, right here, which we'll see in some time. But if we talk about our thread on which all the task was running, if we click on that and take a look at its narrative, if it's possible for us to see, I think the narrative of the task only we can see. When it comes to the thread, it gives you the information, um, saying that the task execution interval information. And if we select that, we can see all of our tasks. If you select this one, it will say the line is here. So we are right here. And this is the starting of the third, fourth, fifth. And that is all there is actually. If there is anything else, let's explore that one as well. Okay, so we can click on our application and actually go to summary hangs. So it says severe hang, the count was one. So we had one long hang, right? In between, our thread was not free, just immediately took the second, third task, fourth task, and so on. So it was not free even for a single milli or microsecond. So it was a one big long hang. The minimum duration was 30 seconds, which is basically the 5 seconds of each task. So we have 6 tasks. So 5 multiplied by 6, 5 6 are 30, and 30 seconds is the minimum duration. Average is 30 seconds, and the maximum duration is also 30 seconds. Yeah. So this gives you the summary about the hangs. If you click on the second one, it tells you the same thing, but it tells you only about the duration, the hang type. So it was a severe hang. It means it's just the hang which is going to occupy your main thread for a very long time. It's gonna leave it until the whole thing is done. You have to close the application if you really want the hang to over. So that's why it tag it as severe hang. And hang risks, if there were any risk behind the hang, it will showcase here. As of now, it doesn't have any data. Thread execution interval, we just saw. All the tasks are just straightforward mentioned here, which is so amazing. And let's explore the profile. So it talks about the symbol names. It is more complicated version of the task execution interval, really. Generally, we don't need to come here and explore the dynamic libraries, as we can get along with the task execution interval most of the time. Let's explore samples. So it talks very much in detail about all of our tasks utilizing what all cores of the CPU. So this is a much more detailed version of uh, what's been happening at underneath, but we don't need this at the moment. And in the app lifecycle, we have only one line says target was not launched by instruments, so the state is currently unknown, waiting for the next state transition. So it actually doesn't talk much about the lifecycle, but just for the sake of exploring this at the moment, we are just looking into it. But it's really the task execution interval which gives us a lot many information about application. And I would say that would be all. Now this is a problem, that our main thread is getting hanged. Now let's talk about the solution to it. So the solution is, since right now our compression code and the UI code is running on the one single class and is in one single class and running on main thread, we need to separate this code. So what we will do is we will create a separate actor for our compression. And let's see how we do that and how it will reflect in the performance. So let's minimize this and let's make it large. What we're going to do is the compression code, which is this code, we are going to create a separate actor for it, so that our main thread is responsible for only showcasing the UI related uh, updates and running the UI related code, and we will keep our compression code on the separate actor. So let's do that quickly. I'll copy this and create a separate actor here. So I've created the actor here and named it compression actor, and we have moved our code of compression right here. And we are having the code for the UI update right here on the main actor. I will stop the application and I will rerun it, and let's see how our application responds now. Let's run it now. And before we start running and capturing the data, I will mention the problem here in the end of our code. So here I've mentioned the expected behavior. The app UI will freeze while the compression is running. Profiler will show severe hang usage on main thread. The lesson is never do heavy work on main thread. The main thread is actually meant to do only UI related work, and heavy lifting like compression of the file or making API calls, which is fetching huge amount of data, you have to do it on separate threads, other thread other than the main thread. So let's skip this video till here, and I hope you find this video informative so far. In the next video, we'll run this application and we'll see how the actors are resolving our problem of the UI hang, since we have now separated the code of compression on the actor, and the UI update or the UI related code is on the main thread. So I'll see you in the next.